Hello everyone, my name is Burhanuddin Rashid and today I'm going to talk about Unity integration with Flutter and native apps. So how many of you have worked with Unity? Any game development related to Flutter or something like that? Okay, and anyone integrated existing Flutter app to their native Android and iOS? Okay, cool. So first thing I want to clear, this Unity integration does not mean to add games into existing app. This is more about you picking up a small piece of Unity 3D rendering and putting that into Flutter and native apps. So yeah, I'm a software engineer and I'm a Google developer expert in Dart and Flutter, so it's been 7 years. So yeah, so today we will cover what's the problem, uh, scale of the problem, then integration challenges, I mean for each platform, for Unity, Flutter, Android, and iOS. And then how does the AI role plays into this integration, how much it supports, and then finally we'll get to the conclusion, okay? Now first thing you will be having in your mind is that what I'm talking about Flutter and native apps, I mean like if you are trying to integrate, it should be just straightforward Flutter, right? Why there's a part of native app, right? But just wait, I'll explain what I mean. Before I start, you need to understand the scale of the project because that is really important, that how big this project is. This project has around 20 million users. It has 50 plus modules and divided into 3 teams, then 25 engineer, out of which 7 are Flutter dev, and then it's also support for web, not just Android and iOS, for some user, like B2B user. Then file generation in your local machine, it will take around 25 to 30 minutes. That much amount of file generation happens. And on CI, it will take one and a half to 2 hours to get a build out. And there are a lot of feature flags through coming from Firebase config, and there are a lot of feature flag in the code as well. And then there are a lot of code around A/B testing, and also every click, everything is going through some analytics. So there is an analytic code also added in there. And the last one is main branch is updated every 2 hours. So if you are late for a day, then you will have a lot of conflicts in your feature, so you have to update your main branch every day. And every 2 hours, it get pushed, something new pushed on a main. So here is an idea of what the app is. So there is a student who want to learn a language called speaking English or any other language. But let's just take an example of learning English. So someone want to build an app called Olaf app, which basically a character. You talk to him, it can talk to you back, so you learn English that way. And there are other games to play, like one word, one sentence, and conversation going between you and the Olaf, so that you can learn it. Now, before Flutter, since it's a very old app, around 10 years old app, so before Flutter, what was the way to build this app? It was to build natively in iOS and natively in Android, and then just give it to the user who has it. But after a few years, I mean, it happens with all the companies, right? After a few years, they realize that their apps is not native feature specific. Like, they don't rely on a camera, they don't rely on location. They have all just is data and the UI components which they have. So they realize that we are repeating the same code again and again on both platforms. Let's introduce Flutter in between. But the problem here is that they cannot directly add Flutter and remove everything. They have to have an intermediate in between. So they started building Flutter app. Whatever there was existing, it was working like similar, but they're starting adding new feature into this Flutter app. So the new feature comes into the Flutter app, and then you integrate your Flutter app as an library or a module to those native apps, Android and iOS. Now, after several years, 20% of features are still in the native Android and iOS, but majority of the portion is in 80%. Now, you might ask, why not migrate everything? Because there are some feature which has been used by legacy users who are also business users, so they have paid for it, so you cannot migrate that. So you have to support both. So we are in a between where you have also Flutter to support and you have native Android and iOS to support. So what's the problem here? So the app started simply with, you speak to it and have a conversation. Then it evolved to have some character, 2D character, which interacts with you. So it makes your app more interactive. And then they thought 2D is like becoming boring now. Let's have a 3D, so that at least you have a feel of some character in between. And this is where Unity comes into the picture, where you want to have a 3D model in it. Now you might ask, why Unity? There are other options as well. Why you choose Unity? So we look into Rive, but it does not give the 3D feeling of it. Then we tried GLP format. They work, but they don't have mesh support, so that the lip sync doesn't work. So when a character speaks, it should also animate properly. So it does not support in that. Web view, it's very slow. And you can say there are a lot of AI gen solution like character building and all, but it's very expensive to do that. And this is more of an experimentation to start with, whether to see if we can make it work or not. And if it works, user like it, maybe do it in the future. So this is the existing structure. Now we want to add our Unity model in Flutter, and also it should work integrating with native iOS and Android. And this is where everything comes together. Now, when I joined it, I thought you are the Flutter developer, you have to work on Flutter apps. But when we got this Unity project, you are not a Flutter developer anymore. You have to know Flutter, obviously. Then you also have to know Android, Kotlin, Java, and you have to also know iOS, Objective-C, and Swift. And then you have to also know Unity and C#. So you're not Flutter developer anymore. You are doing a bunch of stuff. So when we initially estimate, we thought we would able to, how much it's gonna cost, right? Unity, integrated, and done. So we gave an estimate of 3 weeks. Now I'm gonna ask, based on the previous content, how much time it actually took to go to the production. Can anyone guess? Anyone else? Dude, every year I change a job. You are talking about 3 years. Cool. So it took 3 months. So 3 weeks turned into 3 months. How easy it sound? But take 3 months to us. So this was the existing workflow. And I think there is a talk happened previously, add to app, where you have an existing Android and iOS app, and how do you integrate Flutter in it. I'm not going to go much detail on that because this is very well documented. So I'll just give you an overview that how add to app works. In Android, you basically build an AAR file, which is a kind of a library or a module. Then you have this whole structure where you get the builds, and then you integrate it in your native app as a library, and that it works. So there's a lot of things to be done, but I'm just keeping it very short just to get going. Similar to iOS, you have this folder structure, you have to keep it like that. You can check out in the documentation. You add your Flutter path to it, where your Flutter app is built. And then you do post build pro, post in pre-script running, and it will basically build that pod file for you so that you can integrate in native iOS. So basically, you need to have a pod file and AR file to get integrated in native Android and iOS. So this is the existing workflow they have. Now, we have a user, and we want to integrate Unity into this picture. So now, Unity get integrated into Flutter, and Flutter will generate a Unity embedded pod file and AR file for both Android and iOS, right? So far, so good. Clear? So that is how the existing workflow was, and now the new workflow. Now, before we start, we need to understand how Unity works with the Flutter, because that is our second layer. The first layer is the Unity itself. This is our second layer on how Unity will work with Flutter. So this is our app. Unity have a native UI view where the Unity get render on a native side of iOS. And for Android, it's a typical Android view where the Unity gets loaded. And then you have a method channel in between to communicate what to render, what not to render, when it's loaded, when it's not loaded, when you want to animate, when you don't want to animate. And everything this is done via plugin, right? And obviously, like this is very common, right? So why you want to, reinvent the wheel? So this is how it usually look from a demo perspective, that you have a cube, and from a Flutter, you are controlling it, and it's just moving in your Unity view. Now, why we want to reinvent the wheel? Like there is already a widget called Flutter Unity widget, which does that all these things for you. And you can go through that big documentation on how to do it on Android and how to do in iOS. By the way, you have to do it because that's how the integration works. So this is the integration part of it, but I'm not going to explain this. I'm going to explain what are the challenges we face while doing this. And then once that's done, you export a library. You build your model, you export your library for debug, Android debug release, and for debug for iOS, for debug and release both. Now, when you export that library, both are for different framework. For iOS, it will export as a Unity library. It's a whole folder, which is a library. And then there is a Unity library similar to, but for the Android. So this is how you will integrate that into a Flutter, and then it will go to the native side. Now, to integrate into native, there is a folder structure where you have this Android folder in the Flutter. I mean, pretty much everyone would be aware about it. And then there is an iOS folder. So you have to integrate that into your Android folder, and then here is your Unity library, and then you have to make changes in your Gradle to tell the Android app that this is the library you have to use. Similar for iOS, you have to add this Unity library and then make changes in your pod file to tell that this is the library you have to use. Now you have to be very careful because this file get around 500 of MB. You don't want to put into your Git version control, and once it get built, it goes to around 1 to 2 GB. So don't please push this into your version control. Because of that, it creates new challenges, which I'm going to cover later. So now you have Unity library embedded in your Flutter app, and it will build as an AR and pod to your native. Now let's start with challenges with Unity. What are the challenges? So the setup and all that done, but the first problem you will have is version mismatch. So like we run multiple Flutter version, right? And also NVM, FVM and NVM. There is a tool called Unity Hub, which measures different version of Unity. And every few months, it gets a security warning and it gets updated. So you have to keep track of this Unity version, what you are using. So you have to keep it static and make sure that it works with all the version. So you have to make sure your Unity version, your Flutter version, your Kotlin, your Gradle, and your iOS version should match in a way that it should compile. And if it doesn't match, you have to keep trying different version, go to the GitHub issues, find it, whatever version works, just make sure that it is documented somewhere that these are the version it's going to work with. You will spend a lot of time on figuring this out, that what version it will compatible to. People who have worked on Android knows that how Gradle version get messed up. This is like 5 level above. So, and learn a new IDE. First you learn IntelliJ, then you learn VS Code, now you have a cursor, now you have to learn how the Unity IDE work. I'll just give a brief overview from a coding perspective, that what you see and how it's different on the Unity IDE. So first, you don't see the code directly. You see folders here, and your models goes inside this scene, and then there is this model which has, this is the scene where you have those models. And you can see this is the model. I have spent a really good amount of time on just setting up the angle so that I can see the cube. So you have to learn this idea on how to make it work. Then there are scripts. So first, when I click on this demo, I thought maybe all the files should be in that demo folder, but it doesn't show up there. It shows up on the right. And then here are your script, which allows you to rotate your cube, do any animation, all kind of stuff happen in this script. And this script is built in C#. So if you want to make a change, you have to learn C# in order to make some changes in it. So yeah, this is just rotate.cs. It can be any animation. Nowadays, you can use AI to generate those. I mean, just simple animation. So yeah, And then there is a game manager. I mean, you can name any file, which basically takes the event coming from the Matter channel, and based on those events, it performs the actions. So this is the script where you make most of the changes. And then this is the export version of it. You export different build. For debug, there is a different. For release, there is different. For iOS simulator and actual device is also different. Then there is a player setting where you define what you want in your Android, like the resolution, the graphic engine you want to use, the architecture you want to use, all those stuff. And the second challenge is the dev cycle is really slow. So first of all, we become Flutter developer because most of my experience is that people were annoyed with Android Gradle. It was taking so much time, and when they use the Flutter, they see the hot reload and they were like amazed at how it can be very fast. So we are used to that cycle, but when you come to the Unity cycle, it's very slow. Because let's say if you want to make changes in a model, you have to make the script changes here, and then you have to export that change as a library from here, and then you have to add those library in your platform folder specific to Android and iOS. So that much time it takes to make sure that you make that one changes works very well. And there is a one simple solution to this problem, right? Hire Unity dev, right? We were fortunate enough to have a Unity dev which help us out throughout this process so that we learn the IDE faster, how to demo it, how to see the changes itself in the IDE, and also helping us on the integration part of it. So if your company can afford it, please do this first, so at least you will remove that slow cycle. Now, let's go to the challenges with Flutter. So the first challenge is not, related to Unity, but more of a how we design it. So we want to have this as a modular widget. So far, if you put a game inside the Flutter, it would be a full screen game, mostly. And like, it will be a new activity coming on top of another activity, and that's it. That's run independently. It's just need an entry point from your Flutter app. But this time, we want the widget or the Unity render can be placed anywhere in the app. It can be like this on top, and there's a mic in the bottom. It can be in the bottom, and then can be chat going overall. So it should be independent. It should be a small view which you can add, a small widget which you can add anywhere. So yeah, that's the first challenge. And the second one was multiple build types. And I think this will remain throughout this session, that this build type was really pain. Because for Android release and debug, you need to have a different build. So if you are running debug, that's fine, but you have, on the release, you have to use a different export. And in iOS, it gets trickier because for the real device, you need a different with the debug and release, and for the simulator, you need a debug and release. So total, you have 6. And I have not started window yet. So, and one thing we found initially was, since it's not a prototype, what we want to do is we want to add the assets model in the app itself. So the scripting part is different. We want to have a model which can be changed anytime we want. So we have this one Olaf Unity model, which, let's say if we want to change with Anna or any other character, we can just add it there and do it. But while doing that, we found that, if you directly try to get an asset and try to load into the Unity, it won't work. Because the asset bundle on Flutter is stored different compared to the Unity, which is trying to get the folder from the native side of it, is different. So what you have to do is, you have to get the temporary directory of your native part, and then move your asset to those directory. And you have to do it for the one time only, because you can add a check whether the file exists or not, and then you just skip that. Then we had an issue of AAB 200 MB size limit. So, if people have deployed Android app, they know that currently they have a limit of 200 MB. You cannot go beyond that to upload on a Play Store. Now, why we had this issue? Because initially we put that model into the asset itself. So this is 25 MB and this is 25 MB. So it costs double because we have to load a different model for Android and iOS. So existing app was around 160 MB, then you add 2, then it become 210 MB. So after certain period of time, we found that it's better not to load it in there. Just better option is to create a new module called model downloader, which basically download that module and store it in your local. Then we also found a way that you can also remove majority of the size by having less NDK filter. So for example, if you export that, you will see an option of ARM v7 and 64, and we don't need for Chrome and Magic Leap for that Unity feature. So if we use only those two for the Unity, it won't work for other NDK filter. So when we had this, we remove this filter, so because we were not needing it. We were only required to have 2. And this reduced the size of APK around 10 to 12 MB. Then we also had an issue that the model was very heavy and it was not loading on some devices. So we added a modal device compatibility check, which checks the RAM, the OS version, and the memory they have left, how much the app has consumed and all that stuff to see whether it will be able to load the Unity widget or not. Now let's go to the challenges with Android. Building an AR file. I mean, that building module of that AR itself is very challenging, and there are multiple steps we have figured out that where you can face the issue. One is the NDK version, which will be different. Then .android regenerate. I'll explain that later, but if anyone had worked on add to app, they know what this .android folder is. Profile type mismatching, and some metadata mismatching, which we found while integrating it. So let's go to the NDK version. If you go to the documentation, you will see that it recommends to hardcode the NDK version of the path, because Android might be running on different version and Unity might be running on different version, so you have to use the same version. So make sure that your NDK version of the Android which you are running and one of the Unity are the same. And this is the part of the first where I said that the version mismatch causes a lot of issues. Now, .android regenerate, what's it all about? So earlier, we saw that there is a Unity library and there is another Unity library for iOS and Android. Now, we embed this library, if you have remember, that on the Android folder and the iOS folder, because that are the native build of it. But when you generate an AAR, you don't get this folder. It gets regenerated every time. And this folder are called .android and .ios. And if you have known that anything start with a dot, it's something is a hidden folder or something which is not part of a version control. So every time we run flutter.pubget, it gets removed and it gets regenerated. But we want our Unity library to be part of those two, like for .android and .ios. So every time if we run flutter.pubget, it will get removed. Then again, we have to add those libraries. Now, the obvious solution for this was to add a bash script. And that script basically downloads your Unity library where you have stored, I have showed Google Drive, right? It can be AWS, Google Drive, or any other storage you have in your company. It downloads that in your local, and then it moves to your .android and .ios after the pubget is run, so that you have that in your native integration. And then you also fix the NDK version, that whatever version by regenerating is happening, since you have hard-coded that in your script, it will remain same for Unity and same for your Android version. And the another issue which we faced was profile type. What usually happens that when you export from this Unity plugin, which does Android debug and release, it doesn't have the profile type. And if you see the add to app flow, you will have a Flutter profile AR generated for it. So when you export it, you don't have that Unity. So if you go to the Unity library Gradle, which we have earlier exported, you don't see the profile type of it. By default, it will have a debug and release, but it won't have the profile type. So we have to manually add it to that unity.gradle to make it work. So the profile type was missing. And this seems like, oh, it's just a 1-minute fix issue. But we spent around 3 days to figure it out where this issue is, why the profile is not matching. Because we thought it might be the issue from the Flutter app itself or the AR part itself, but it was the issue inside the unity.gradle, which was exported from the Unity, because it doesn't know about Flutter. It just export Android and iOS. Flutter is the only one which has the profile type. Apart from that, other doesn't have that. So we have to manually add them. Another issue was, since it was manually exported, it was missing metadata issue, which required version number, version name, parent class, where it's coming from, when you are building that AR. So it was missing. So we added this in the Gradle so that it ignores it. And then there are many tons of other fixes we have done, small fixes, like what if you are using an existing jar in your Flutter app? How do you move to the native side? How the Unity get integrated to it? So there are small fixes which I'm not going to show here, obviously, because it will take a lot of time. But we did all that, and we created a bash script again, which has a working.gradle. We created a working.gradle where all those fixes which we have done, put it in that Gradle file, and it was part of the script. And when it gets run, it will copy that same Gradle. Sorry, it will copy. Sorry. It will copy the same Gradle to the build.gradle file. Okay? So that's how we basically use a lot of bash script to make this work. Now, challenges with iOS. I mean, iOS is very challenging in a sense. The first one is Xcode and Pod. And Apple being Apple, they are really good at UX, but really bad at developer experience. I mean, their tool is like, I don't know, I can't say anything. So you have to have, I'm just going in a short, that you have to play around with the Xcode in order to make it work. Like, you have to have a Unity iPhone module there. You have to go to the runner. First, you will take a time to where that runner is. You have a really hard time to find that. And then you have to add those frameworks. And for every simulator and real device, there are different versions of it. So this is the second challenge with the iOS, that you need a different file of a simulator and for the real device. Android doesn't have that. Android have a debug and release, but here it's additional because simulator required different architecture and real device required different one. So you have 4 different Unity export. And it's very hard to version control this. How do you version control Unity model? How do you version control which model is there? How do you know which export is this? If someone else come in and update it, then it might not work. So it was very tricky to work around this, all those things. And other issue was lifecycle issue. Since it was running native iOS, it has its own view, UI view, which is currently running, and the Flutter apps run on top of it. So you have a different lifecycle issues where Flutter is running on a different version and native iOS is running on a different version. But the Unity is attached to the native view and not the Flutter view, and the widget is just rendering that native view part of it. So we had a lot of issues where if users minimize the app and come back to it, it crashes because of the lifecycle mismatch issue, because the iOS app is already started, but the Flutter engines are not started, and we are trying to render the Unity widget, but the Flutter Flutter engine has not initialized yet. So there is a lifecycle method here called will terminate notification. Since it was causing issue to us, it was causing issue here. We added a fix here that we check first if the Flutter engine is enabled or not, then only it called terminate, otherwise don't call it. Now, you might be thinking how the AI is supported in all this. And if I be honest, absolutely nothing, right? It's a moment like if you have watched, Kung Fu Panda and you are trying to open a dragon scroll, it's nothing, right? It's not AI, it's you. You have to tell AI what need to fix, right? I don't know what's going on with the integration. How do I tell AI to figure it out? So AI did not support us in many ways. In a much bigger way. It was having too much context. How does it will solve a problem which require you a Unity, you need a Flutter, you need an Android, and you need iOS. all this code base cannot be compiled into one to make sure to figure it out the AI on what's going wrong. And to be honest, we haven't wrote bunch of a Dart code in a sense. If you have seen my slides, all are pod fix, Gradle fix, and Unity fix. Actually, feature were built on a side, but from an integration perspective, all are this file we made changes to. So we didn't write much of a code. So it didn't help in that way. And also, it's not help in building the feature end-to-end, like 2D or 3D working of it. We have to manually done those changes and see if it works or not. However, I mean, AI supported us in many ways. I mean, it's not like it didn't help at all. I mean, one was writing script. So the bash script, which I was talking about earlier, if I am a noob here, it would take me some time to understand the syntax and do the downloading and copying and all that stuff. But if I have AI in a place, I just tell them to write the script, and it basically writes it. So it was very fast in a way to write those scripts so that we were able to fix those changes very fast. Then version matching, as I said, NDK, Gradle, Kotlin, iOS, all those was fixed through the linting. So all those scripts were fixing that. Download Unity library, and the model downloader, which basically downloads it, save in your local, maintain a progress, show the progress, and all that stuff. And also the compatibility checker, where you can check whether it's suitable for this device or not, what is the RAM and all that. It was pretty straightforward to write all that down because it just need a package and try to get that. You define your configuration, what you want to do, and it's basically write that code. So it helps a lot in that sense. So, yeah, so the future Unity improvement, I mean, I can think of, I mean, this is not like done end to end. It is just our first phase of just get the product out in some way. There are a lot of ways. I mean, if someone is a Unity expert or have been work on, might know that there are a lot of possible things you can fix here, which we realize later. Is that we should have a single Unity library for each platform. There are multiple versions of it. We should avoid that. Then there are pre and post Dart hooks, which allows you to configure things based on your need before the Flutter run command is run or any other command run. So you can do that before and after, so you don't have to write those bunch of scripts. Similar to pre and post build hook from the Unity. So if you remember, we make a changes into a Unity Gradle file also. We can fix that as well from a Unity export perspective, where whenever Unity export, it basically does all those things in the Gradle file, and then we can just directly edit, so we don't have to write the script. And an independent package include all this system. So all you have to do is just do a package adding in your pub spec, and it should work fine. So this is not the current state which we are in. We are looking for something to be done in the future. So yeah, that's the conclusion. And the conclusion is that you are not a Flutter developer anymore. So you don't need to learn Flutter, you need to learn Android, you need to learn iOS, and you need to learn Unity. And if you are a full stack dev, sometimes you have to learn Python, sometimes you have to learn AI, and sometimes you have to learn ML. So that is what the current state is. So yeah, that's it. This is my website. I write newsletter on widgettechsubstack.com, and then there is a classes which I was running earlier. And I work as a freelancer, so if you have any issue with a legacy code base, integration issue, architect your app for your startup, improve code quality, or train your existing developer, then yeah, hit me. And I'm also trying to run a class called Flutter with AI, where you can build Flutter app, but you also use AI in a way that it helps you to build things very faster. So if anyone is interested, they can fill up this form. So yeah, thank you. And I think this is all my QR for LinkedIn, Instagram, and Twitter, and newsletter.